So next, under the inspection and testing series, we are going to be looking at induction motors and generators. So we are going to look at both of them together, since both of them are a kind of similar. The only difference is that the generator is converting rotating mechanical energy into electrical energy, while the electric motor is converting electrical energy into rotating mechanical energy. So as usual, this inspection and testing, we are going to do it in two parts, okay? So there are two areas that we are going to be looking at. So we have the physical or mechanical inspection, which has to do with the visual inspection, and then we have the electrical inspection. So those are the two categories of inspection that we will be doing on the electric motor and generators. So first, we'll be looking at the physical inspection. Okay, so during the physical inspection or the mechanical inspection, what we need to do first, especially for newer units, is to look at the nameplate information of either the electric motor or the generator, to see that it actually matches the specification. Or we can also compare those nameplate information with the drawings, okay, if it is already an installed unit in our installation. So as you can see on the screen, this is the nameplate of the generator alternator. So this is the nameplate of the electric motor. So here we have the nameplate. So if you look at the nameplate, you'll see the power rating of the generator. So on this we have it as 100 kVA or 80 kilowatts. Okay. Then if you look further down, you'll see the voltage rating. So it can be configured to either give us 400 volts or 230 volts. And then this is the amount of load, that is the rated current, the maximum load that it will carry. Okay, so these three parameters are basically the most important parameters that we'll be looking at for now. Okay, then if you look at the specifications, maybe the speed, the RPM, we may have it specified. Okay, so and if you look here, you see the RPM. Then the frequency of operations, we also have them specified, and the number of phases, 3 phase. Okay, all of this may have been specified. Then the environment where we use this equipment actually determines the ambience. The ambient temperature should be less than 40 degrees Celsius. So when we compare this information with what we have on the specification sheet, that will tell us if what we are procuring or what we are installing is what we actually needed in our installation. Then we can also compare it with the drawings also. So on this single line diagram, which you have seen before in our earlier series, so this is the generator through the breaker to the main bus. Okay, so if you look at this bus, you see that the voltage output here, the voltage on the bus is 4,160 volts. Okay, that's 4.16 kilovolts. So what this tells us is that, or what this is telling us is that this generator should be able to generate this amount of voltage. So if you have this kind of information, it means that the output voltage here should be 4,160 volts. So again, you also look at the load that the generator will be feeding, which will be clear on the single line diagram too. Okay, so the load on it will determine the current that will be flowing through back to the source, that is the generator. So that will also determines the amperage of your generator. So these are the little features that you look at, okay, to determine that the generator actually meets the specification that you actually want. So on the electric motor, you also look at the nameplate. You also do the same comparison. This is the power, okay. You also check it to see the horsepower, to see that it matches what was specified on your specification sheet. This is your output voltage, okay. That is the input voltage, I mean to say 230 or 416. So if it is something that will be installed here, it means that this voltage and the voltage at this bus should match. Then this is the current on that is the amount of current that this particular electric motor will be exerting on the circuit, okay. So if it is running on 230, this is the amperage. If it is running on 460, this is the amperage, and this is the frequency, and this is the phase. So all of these you check to see the speed to the RPM, the ABS, and the duty, which means that it can be used continuously. So you check to see that it actually match what is specified. So if it matches, then we are good. We can continue with either the installation or ascertain that what we have there is actually what we wanted. So you also carry out other physical inspection. You look at the frame to see that it is clean. The anchorage, the hold down bolts, you also the hold down bolts on the electric motors, the alternators, you check to see that they are firm. You can even torque them to ascertain that they are up to the specified torque level with your calibrated torque wrench. Okay, so you check to see that they are firm. Then the grounding too, if it is installed, so you check to see that the grounding on each of these equipment, they are firmly terminated. So all of these are some of the things that you check to see that the generator or the electric motor is actually fit for use, or it can still serve its purpose properly. Then on the electric motors too, you check to see that it is neat, these cooling fins, that there are no deposit or debris covering them or in them. So if there are, you clean it up to ensure that the cooling air from the fan can flow through freely through the cooling fins. If the cooling fins are blocked, that can increase the running temperature of the electric motor. So you want to check to see that they are free of debris. Then the shaft, you can turn it to see that the shaft is free. If it is not free, maybe if the bearing is 40, from experience you'll be able to determine if the bearing is 40 or will not serve its purpose. Then the cooling fan on the alternator is, since this is a direct coupled alternator, is usually on the rotor. Okay, so you can open up this shield. Okay, you can open up this shield and turn the rotor to see that it is free. Okay, to see that it is free, because the rotor usually is engaged to the flywheel that is attached to to the engine. Okay, so you check to see that it is freely rotating, and if it is freely rotating, that will mean that it will be able to serve its purpose. So those are some of the things that you check out, you inspect during your physical or visual inspection. You check to see the mechanical conditions of the equipment. So you also look at these the air filters, the these cooling filters as we said before. Then if the alternator or the motor has brushes, you have to check to see that the proper tension is maintained between the brush and the slip ring. So those are some of the things that I want to be very sure of, because if it is not the spring pressure on the brush is not enough, that can result to partial contact that may eventually result to arcing, and a continuous arcing can result to the damage of that slip ring and the entire unit. So you also need to make visual inspection of those electrical connections to see that there are no signs of high resistance. Okay, all of these connections. So like we discussed in our earlier series, the signs of high resistance, they are usually those metal oxide deposits, those whitish and the greenish substances. So if you see them on these terminals, that goes to show that we have a kind of hot spot around that terminal, which may be as a result of either loose contact. So we'll see those other deposits here. Those are signs of high resistance. So if we see them, what we need to do is to loosen, clean up, and then tighten back. Okay. As we'll see later, we will need to apply the right amount of torque at all of these terminals. So if we apply the right amount of torque, that will help the system to work properly. So we can also use those low resistance meter to test the resistances at this terminal connection or terminal points. Okay, so we can do that by, this is directly from the, this here, you see these cables, they are directly from the windings. Are we getting it? So we can place our probe here, the low resistance meter probe, okay, and one here, and one here, to get the resistance between that lead and this terminal connection, or this shorting bar. So that will give us an idea of the amount of resistance between this terminal log and the shorting bar. So if it is beyond what it's normal, because we expect it to be as close to zero as much as possible. So if it is beyond what is expected, of course, we need to either tighten up or loosen, clean, and then tighten up that particular connection. So this is an example of the low resistance meter that we can use to test the we'll set it to the micro ohm or milliohm range, and then test the resistance at those terminals, okay, to see that high resistances are not building up. Remember, current will flow through those terminals, and once the resistance are high, the I square R effect will always come in, which means that there will be an increased heat dissipation, which will eventually affect the efficiency of the electric motor, and even develop hot spots that can cause failure of the electric motor at that particular terminal. So all of these bolted connections, we need to use a calibrated torque wrench to see that the actual torques they are applied on these bolts and these nuts, these bolts and these nuts. Okay, so we can compare, or we can use the specified torque level by the manufacturer or by our facility. The one that is specified by our facility, we can use it as a guide to apply the required torque level on each of these nuts. So if our facility does not have any specified torque level, or the manufacturer of the equipment does not have any specified torque level, then we can use this table. Okay, so if you look at it, you see that different grades of bolts, they have different torque level, both of the same sizes, but they are of different grade. They have different torque level that you apply to them. Okay, so if, for example, the bolt that we are looking at, this nut is a half-inch nut, as an example, what it means is, and maybe the grade is SA5, what it means is that the amount of torque that will be applied is 48 pound-feet. Okay, so we'll use our torque wrench, the calibrated torque wrench, as you can see on the screen, to do our torquing. So the next thing we can do, if we can assess the gap between the rotor and the stator, is to test the air gap. The air gap, that is the space between the stator and the rotor. So if it is more than what is required, that is, if it is more than what is specified, that means something bad is actually happening in the, maybe it is rubbing, we don't know. And we know that air gap, if it is not uniform around the stator, it will affect the operations of the equipment, either the generator or the electric motor. So we want to be sure that the air gap is uniform. So we can use test equipment like this. Okay, so as we insert it, the spacing in millimeters of the millimeters, okay, of the space between the rotor and the stator will be registered in the equipment. So we use this air gap measurement device to determine that we have a uniform air gap around the electric motor. So another, the electric motor or the generator. So another test that we can do under the physical and the mechanical test is to do alignment test to be sure that the equipment is aligned. So as you can see, we can align the driven equipment to the driver, which is the electric motor, ensure that it is aligned, because if they are not properly aligned, that will exert excessive stress on the bearings, okay, and that can eventually lead to bearing failure. I will know that bearing failure will eventually lead to failure of the machine itself, cause other problems like causing the rotor to rub, and once the rotor is rubbing, can eventually result to burnout. So those are some of the things that we need to check as we are doing our physical and mechanical check. In generators, remember, they are directly coupled, so we may not be able to use this laser alignment equipment to carry out those tests. So basically, we will do this on the electric motor in the field. So we also check the shaft for runout. Okay, we can use the dial gauge to ensure that the shaft round is uniform. Okay, so as we are rotating the shaft, once we connect the dial gauge, as you can see, as we are rotating the shaft, if there is any run out, you'll see that it will cause deflection on the gauge. Okay, so we have what is acceptable and what is not acceptable. remember that runout will affect the alignment. If the runout is beyond certain level, no matter how you do the alignment, it will never ever be aligned. So we want to ensure that the alignment, the runout is something that is tolerable, is acceptable. Okay, so that will help us to achieve that precision alignment that we need on the equipment. So on the generator, like we said earlier, it is directly coupled to the engine. We may not be able to access the coupling point, okay? But we can, if it is possible for us to assess the space between, from the front, the space between the rotor and the stator. Of course, we can measure the air gap between the rotor and the stator. So the next section of tests that we are going to be looking at for the electric motor and the generator is the electrical inspection, or the other part of it, which is the electrical test. The major tests that we are going to be looking at in this section is the insulation resistance test, the electric withstand test, resistance test, okay, that is checking the resistances of the windings. And also we are going to be looking at the power factor or tan delta or dissipation factor test. In the insulation resistance test, what we are actually testing is the insulation between the phases. So we'll disengage these bars, okay, and test the insulation between V and the U phase, and then the U and the W phase, W and the V phase. So you test the insulation between the phases here and then on the generator too. So since it is starred, it will be very difficult for us to test the insulation between the phases here. But if the star point is brought out, it's just for us to disengage like this now. We can disengage the star point, okay? This is a delta connection, but if it is starred, we can disengage the star point and then test the insulation between phases. But here we can only test the insulation between the winding and ground, okay? But in this case, once we disengage these shunting bars, we can test the insulation between the phases and then between the phases and ground, as you will see in the video that the link is dropped in the description below. So for equipment that are larger than 150 kilowatts, we should carry out the test for up to 10 minutes. Okay, so that we'll be able to calculate the polarization index. So if the machine is less than 150 kilowatts, we can test for 30 or 60 seconds, and then we calculate the dielectric absorption. So all of these, they are done to ascertain the integrity of the insulation of either the electric motor or the generator. So on larger equipment, you perform the dielectric withstand voltage test. So the next test you want to carry out is the resistance test. You know, since the windings, the UV and W windings, they are made of the same materials, the same wire size, the same number of turns. It is expected that the resistances of the three windings will be the same. If you have your milliohm resistance meter, you turn the selection switch to the milliohm test range, okay? And then you probe. If it is the U phase, this is U1, U2. After disconnecting it, you probe between U1 and U2. It will give you a resistance level, you register it. So that is, then you probe W1, between W1 and W2, and then V1 and V2. So since the windings are the same, you expect that the resistances should be the same. So if there are variations, the variations should not be more than 2 or 3%. So if there are variations, that means something heinous, something dangerous is happening within the windings. So you need to check that out. Then for generators, remember it has been starred. So the start point is this neutral. So you can measure between the neutral and line 1 will give you the resistance of the first phase. line 2, second phase, line 3, third phase. So all of those will give you the resistances of each of those windings. So it is very important that you measure these resistances, because a little discrepancies in that resistances can cause imbalance in those high voltage equipment. So the next test is the power factor or dissipation factor test. In the power factor and dissipation factor test, you're actually checking the integrity of the insulation. Then after installation of the equipment, you can check the vibration levels. So the vibration level should be within tolerable limits as specified by the equipment manufacturer or by your facility. So in the absence of it, you can use the table here as a guide to ascertain that the equipment is not running beyond what is acceptable or tolerable. Once the vibration is high, it affects the operations. Too high, it affects the operations of the equipment.